Example 4, if f of x is equal to the square root of x, find the derivative of f and then state the domain of f prime. So what we're going to do is, again, we're going to use the definition that we know, which is f prime is the limit as h approaches 0 of that formula. So we want to find the limit as h approaches 0. So the first part, x plus h, becomes the input. So we have the square root of x plus h minus the function, which is the square root of x divided by h. Okay, so now what we want to do is we want to go ahead and then multiply the numerator and denominator by the conjugate. So we're going to multiply the numerator by the square root of x plus h plus the square root of x, divided by square root of x plus h plus the square root of x. So now let's go ahead and simplify that. So when we multiply the numerator together, we have the difference of squares. So when we multiply that, we get the square root of x plus h times the square root of x plus h, which leaves us with x plus h. And then minus the square root of x times the square root of x is x. And then we're going to divide that by h times the square root of x plus h plus the square root of x. Okay, so now that we know, what we can do next is we can then simplify the x minus x, which is 0. And so what's left? Well, we can see that we have an h divided by h, so that leaves us with 1 in the numerator. So we have 1 over the square root of x plus h plus the square root of h, square root of x. And so now what we're going to do is we're going to evaluate this limit when h is 0. So we end up getting 1 over the square root of x plus 0 plus the square root of x, which is 1 over the square root of x plus the square root of x, which, if we combine the denominator, is 1 over 2 times the square root of x. Okay, so therefore there is our function. So we know here that this has a restriction, right? So we know that this restriction tells us what? Well, if we want to find the restriction, the domain tells us that x has to be greater than 0. So if x is greater than 0, then our domain goes from 0 to infinity. And so the domain of f prime of x is 0 to infinity. Now let's go ahead and graph these two just to check. So we're going to graph the square root of x So there is our graph. And that represents our function. And then we're going to graph the derivative function, which is 1 divided by 2 times the square root of x. And so therefore there is that graph. So again, this represents y equals, or in this case, f of x equals the square root of x. And this is f prime of x, which is equal to 1 over 2 times the square root of x. So let's go ahead and summarize the graph and the last part of this. So we see that f prime of x, or the derivative, exists if x is greater than 0. So we found that the domain of f prime of x was 0 to infinity, but we're not including 0 because there is a asymptote there. Okay, this is smaller than the domain of f of x because that domain includes 0 from 0 to infinity. Now, when we talk about the two graphs, okay, when x is close to 0, the square root of x is also close to 0. So f prime of x is equal to 1 over 2 times the square root of x is very large, and this corresponds to the steep tangent lines near here, 0, 0, in the first graph. And the very large values of f prime of x just to the right of 0 in the second graph. Now when x is large, okay, f prime of x is very small. And this corresponds to the flatter tangent lines at the far right of this graph on the left of f of x. And the horizontal asymptote of the graph of f prime of x.